Hey, this is Nick Sensky, professor at UNC Charlotte, and today I'm just going to give you a brief demo of how to integrate Grasshopper with Ecotect. And basically what we're going to do is we're going to use Grasshopper with a plugin called GECO, and that's going to send our rhinoceros geometry into Autodesk Ecotect, where it's going to run some analysis, and then Ecotect is going to send that information back into Rhino. And we're going to be able to play with geometry using Grasshopper and basically see the simulation data in near real time. You know, there's probably a little bit of lag, but the idea is that we're going to be able to look at environmental data like solar data, things like that, inside of our model as we edit it, okay? And the first thing you're going to need is Grasshopper, of course, and Rhinoceros, and then Ecotect. And the GECO plugin, which you can get by Googling, GECO, GECO, and Grasshopper, and eventually you'll find the link for it. People in my class, I'm going to be providing you with a link to that. And once you've got all that, you're going to start with your geometry that you have. And in my case, I just made a simple surface. Nearly everything that you're going to be working with in Grasshopper is going to start as a surface because things in Rhino are surfaces. When I say surface, I mean something that's basically made out of control points, something that's made out of NURBS. It doesn't necessarily have to be smooth, but it's identified as a surface. Okay, most of the things you'll be working with have that property. This is a very smooth surface. What I'm going to do is I'm going to take that, and first thing I want to do in Grasshopper is actually convert that surface to a mesh, because everything in Ecotect basically works with mesh data. And meshes are more like polygons. They're not necessarily smooth. They're faceted, like a lot of little squares or a lot of little triangles. Okay, and in this case, what we're going to do is we're going to simplify the geometry of our surface and convert it to an approximate mesh, and that mesh is what we're going to send into Ecotect. Okay, so the first thing I want to do is just get a surface container inside of Grasshopper. Okay, and I can get the search bar to come up by double-clicking in Grasshopper, and then I'm going to start typing in surface, and then pick surf. Okay, pick the command, right-click. I'm going to set my surface. Now I've chosen my surface, and I'm going to hide the original geometry. Hide in Grasshopper. I mean in Rhino. So now I have the surface that has been loaded into Grasshopper. Okay, so this is the geometry that I'm referencing. Then I want to go in and I want to make a mesh surface. And again, type in mesh, get mesh surface. A mesh surface takes a surface, and it takes UV coordinates. That's going to give you the number of subdivisions in that new mesh surface. So I'm going to add a slider. And the more faces you have in your mesh, the longer it's going to take to process in Ecotect, and the slower the feedback's going to be. So you want to try to balance the resolution of your mesh with the amount of detail that you want to see in your model that you want to analyze. If you don't have enough detail, it's not going to tell you much about your project if you have a lot of curves, for instance. But again, too much is going to make things slow. So we want to strike a balance, and this is going to allow us to interactively change that balance so we can see the number of faces that are in our mesh. So I'm going to start with a slider, and I'm going to make it basically a real number, reduce it to no decimal points, and I'm going to say 20 for that. You don't want half numbers because we're really just talking about the number of quads, and you really can't have half quads or quarter quads or anything like that. So 0 to 20 is fine for now. I'm going to make one for the U, and I'm going to copy this and make one for the V as well. So I can change that. You might want to change the parameters if you have a shape that's longer than it is tall, or vice versa. So having a UV slider separate is a good idea. Okay. One thing that helps to kind of visualize this is a plugin called Weaverbird, and you can download it. Just do a search for Weaverbird, and that's going to give you some additional parameters. And one of the ones that I like that's helpful here is this mesh edges. And what that allows us to do is if I plug a mesh into it, it's going to allow me to see edges of a mesh. You can see these green shapes here. I'm going to go ahead and hide my mesh. So you can see what happens. You can see that I've actually taken my smooth surface and it looks kind of jagged down a little bit. That's because I faceted it to to a mesh. And if I change the U parameter, it's going to change the number. You can see that I have a lot less detail. So you're going to want to choose a setting that's going to give you enough detail so that the solar values make sense to you, that they matter to you, but not so much detail. And if I crank this up all the way, it's very smooth, but now I have 400 faces to process. Okay, and so I want to take a step back and decide what makes more sense to me. Am I getting more variation in this axis or in the other axis? Okay, so again, you won't see that mesh edges thing unless you have the Weaverbird plugin installed. But I find it very helpful to have, so I'm gonna kind of stick that off to the. All right, so now that we've approximated our mesh, we can actually send it to Ecotect for processing. So the first thing you want to do when you work with Ecotect through the GECO plugin is you can go through the extra tab here, drop in this component called EcoLink. What this is going to do is it's going to basically confirm that there's a link between Rhinoceros and Ecotect. Okay, and so it's very simple. You are going to do a Boolean toggle and connect it to Ecotect link. And what happens is that when you double click this, it's going to set this to true, and it's going to test to see whether Ecotect is indeed running, and in my case it is. And if it's not, it'll launch Ecotect. And if there's no Ecotect, then it won't work. And if that won't work, you can't do anything with GECO. Okay, so I'm gonna double click this, set this to true. And you can see, nothing happens, but it actually does say connectivity test with Ecotect successful. Okay, so that's what you want. And anytime you would run a script using GECO, you would need to verify that Ecotect is indeed linked to it. Okay. The next thing you're going to do is you are going to export the mesh from Grasshopper, from Rhino, into Ecotect. Okay. So I'm going to go in and say EcoMesh export. There is a Ecotect link here, so it says if this is true and Grasshopper is connected, so if this is working, then launch this. So what I'm going to do is I'm going to go ahead and set a toggle to false. So this is the switch that's going to turn this thing on. We're going to take our mesh that we made from our surface and plug this in. You can see that this turns gray, which means it works, so it's taking that mesh. You can set a scale here if you need to. If you need to change the scale of it as it goes into Ecotect, we'll leave it up to you. You could extract that parameter that's going to be an integer and change that. These settings you can probably leave to default. So what happens when I do that? Well, if I hit true, and I go to Ecotect, we have our mesh. Okay, so you can see that that has actually gone into Ecotect. Okay. And that's what we want. And then we can start to process. So once I've got my model imported in Ecotect, I've got that figured out, I'm actually going to go ahead and turn off this toggle because I don't want anything else I'm doing right now to start an analysis unless I'm ready. That's going to slow the computer down and just be a big pain. So I'm going to toggle that to false. I'm going to go ahead and drop in a solar calculation. This is going to calculate, the insolation values for my model in Ecotect, and lots of parameters here. But basically, this first parameter here, this E, is going to start the calculation if it's true. This D here, actually, once the mesh import is finished, D is true. So if I hook this up, as soon as my mesh is imported, it's going to start this analysis, which is fine. The next thing I'm going to do is actually I'm going to look for the weather data file here. First time I set this up, I need to do this. So I'm going to go ahead and extract that parameter there. And actually, you know what? I'm going to do a file path instead. Make it easier. File path is I'm looking for a file. There's a particular widget in Grasshopper that lets us look at files. So if I go in and I say set file path, so I right click, it's going to open up a browser. That's easier than doing a string. What I want to do is I want to go into the Ecotect directory that's on my computer. So in my case, I think it's program files, Autodesk, maybe it's x64, x86, Autodesk, Ecotect, weather data, and then you find, in this case, I think United States. Find the closest one, and in my case, if I'm thinking about Charlotte, it's probably going to be Nashville, Tennessee. You can download other weather data and put it elsewhere, but basically you just need to connect this thing to a weather data file. So I'm going to go OK, and now you can see that this is actually turned gray, which means that it has everything that it needs. So at least it needs to be connected so that it can be triggered, and it needs to have a path to that weather data. You can go through these other parameters here, and you can set these things manually. By right-clicking and saying set integer, or you could extract the parameter and set it elsewhere. You could do a slider to set them. I'll let you kind of work through these, but the one that is most important to me is the number of subdivisions in the sky, and because that actually, more subdivisions equals more processing, which means more time. It means more accuracy, so that's something I want to control. So I'm just going to go ahead and make another slider. It's got 0 digits, and it's going to be, I don't know, between 1 and 30, let's say. Plug that into the sky. Just going to go ahead and set this though for 15, which is the default actually. 15 is the default, and that's plenty granular. But then we can change this later if we want to. You could do a slider that has 0, 1, 2, 3 if you wanted to affect the different kinds of analysis you want. I mean, basically, you can set this up how you'd like. Once I do that, though, okay, so this will actually take the geometry and process it in Grasshopper. And why don't we go ahead and try that now? So I'm going to go ahead and export this. I click true. And you can see it's already processed this data. So you can see that for this particular solar installation, you can see that in this side of the bulge, it's actually quite a bit darker. Up here, it's very bright. So this has already processed our model. And what's really interesting about this is if I go back into Grasshopper, if I change the values of this, like let's make it less dense, slide it slightly, like this. If I go back to it's already been modified in Ecotect. It's already been processed. You can see that's less dense. So this is what we're talking about when we talk about that kind of bidirectional processing. So now it's a very, very, very abstract. Okay. So for the next part, what I'm going to do is I'm going to send this back to Grasshopper because I don't have to pan between Ecotect and Grasshopper and Rhino. I just want to see it in the screen, and I can do that. And I'm going to, for this next part, what I'm going to do is I'm basically going to transfer the color data from here, which corresponds to the analysis readings, and display it graphically in Grasshopper, so that as I edit the model, I'll be able to actually see it without going back and forth between Ecotect. Okay, and to do that, first, I want to actually add something to my program. There's a component if you go to the GECO page that's called Mesh Edit, and you're going to download that from GECO and go into your directory and basically drop it into Grasshopper. So just take this mesh edit and drag it into your bar up here, like into your Grasshopper, and then that's going to pop into your tools here. There's some tools for working with meshes that we want so that we can visualize them in Grasshopper. Okay, so one of those tools is actually called Mesh Explode. What that's going to do is it's actually going to fragment our mesh into a separate list of mesh faces. So you can see that. So if I drop a mesh in, I get 64 faces. So which makes sense. 8 by 8, 64. Okay. So we take that mesh and just go ahead and flatten that. Make sure that's all. Yeah, 64 faces. Okay. And then what I'm going to do is I'm going to go into Ecotect and I'm going to do an object request. So I'm going to ask for the attributes of that analysis object of this thing. And that's what I'm going to use in Grasshopper to get the color values. Okay, so I'm going to take the D, plug it into the E, right? So that when this is done, this fires. And then what I'm going to do, this is basically asking. This is telling the program what I want out of it. I want the total radiation from the solar analysis. I can change this 1, 2, 3 if I want to. I'm going to go ahead and extract this parameter, and I'm going to set this to 1. It's already set to 1, but if I change that, I can change my analysis. Okay, it's asking me what I want out of that analysis, and then what I'm going to do is what I need to do is I need to make sure that there are the same number of objects here as there are faces in the mesh, and I want the numbering system of these to correspond to the mesh that I have in Rhino. I need those two to be synchronized. So what I'm going to do is I'm going to look at the length of this list. So I want to ask how many things are in here, and there's 64 basically. So 64, okay. And then I'm going to let's put a number in here. I'm going to take this, and an array in computers, they actually count from 0. 0 counts as a number. So if I have if I have 64 things, I actually have an array of data that counts from index 0 to index 63. So what I want to do is I want to subtract 1 from this to give me the range. So I'm going to go ahead and add an expression, and I'm just going to say num minus 1. So it's going to take whatever that number is that went in there. From L minus 1, I get 63. Plug that into the indices, and that's going to be 0 to 63. So I have 64 indices. Okay. Then I'm going to add a mesh color. Mesh colors component. I'm going to plug in all the faces that I took out of there. Whoa, now I've got some color here. Actually, I'm going to go and hide. Turn off the preview on some of these. If you turn off the preview, it's going to clarify our mesh here. Okay, so we have mesh color. Then I'm going to take the RGB values out of our analysis and plug them into the colors here. And I'm going to go ahead and graft. So right-click graft, right-click graft, so that we can combine one of these with one of these. Okay, I'm going to adjust the data tree so that I get a clear value. Now I'm going to go ahead and run my analysis again. That's why none of this works, because I haven't run the analysis. So if I open up Grasshopper, voila. Okay, I send it to Ecotect, and what you see is what you get. Now, if I dynamically alter this, you can actually see it. It takes a second. It's actually going to display it. Oh, no detail there. It's going to display it inside Grasshopper for me, so as a mesh. So I look at this from behind. So that's pretty nice and interactive. Let me go ahead. If I make this, I might be able to speed things up a little bit. Yeah, so you can see the accuracy just went down because I did that. But the speed might have gone up slightly. Okay, and that's just generally how to get some visual feedback out of this. Now, if you had other things, let's say that you had more than one surface, you would need to convert each one of these surfaces into a mesh and then send all of those meshes separately to Ecotect. You could do a mesh UV for each one. There's also a BREP approximation, so you can actually it's called mesh BREP, and a BREP is a boundary representation, so it will attempt to fit a mesh to any collection of surfaces. The mesh UV method is better because you can actually adjust the mesh density interactively and separately, so you get as much detail as you want for those things. But that's the general way to get this to display graphically. I'm going to post more links to some other methods, but this is the general path from surface to mesh to Ecotect to calculation, and then back into Grasshopper as a colored mesh. I hope that helps. If you have any questions, let me know.